Let's merge this code now with the original code. Before we merge everything together, I'm going to start by merging the LED first and see if it works, develop the code. Because if the LED is working, then the buzzer, hopefully, it's just adding this line of code and these 3 lines of code and everything should be good to go. Alright, so let's go to original code. I'm not going to use this part here. I'm going to use the library new ping. Makes our code cleaner. Alright, so I'll remove that part. I'll remove everything that has my name and comments. I will uncomment these and I will make sure that this code works the way that it should. So I compile. I'm going to turn on my oscilloscope to see if the wave is going to be generated properly. Turn on my serial monitor. Done uploading, and let's test it out, and it's working back to the way that it was working before. Alright, great. Let's keep going now. I don't need these, I keep that. And I'm going to do my own code. So I'm going to comment this part. Several ways of tackling this. I'll probably recommend to do a flowchart first, but if you know what's going on, you can go directly to the code. Because it's a simple code, I'm going to copy and paste things without the flowchart. I need to define my LED pin. Here you go, pin number 2. I need to define the pin over here as an output pin. And I'm going to also do some sort of digital output on this LED high and low, where this is going to come from the distance that I have to my objects. Alright, so the second thing that I need to do is to start my ping sensor. Ping sensor here acquires the data, microseconds. Now I need to perform this conversion over here. Alright, so I'm going to declare another variable called unsigned int distance. So I convert my microseconds round trip to distance. Now that I have my distance, one way of doing this is a bunch of if statements and comparing the distance with some thresholds, and then have that adjusting the timing. There is a function that is very useful in Arduino, which is called map function. In the map function, you give a value and you give a set of ranges here, the lower bound and upper bound of the current value, and then you give the lower bound and upper bound for the new value, and this function will map it, and that's what I'm going to use. So I'm going to copy this, go back to my code, and unsigned int, this is going to be my alarm. I'm actually going to declare this here and have the alarm declare that variable and initialize with the value. I'm going to say by default is going to be 1000, and this is going to be related with milliseconds for our LED to blink. The value that I'm trying now to map, it's my distance. Minimum value, I'm going to put 10 centimeters to 100 centimeters, and I want to map that to, remember, 150 milliseconds was the minimum for our buzzer. I'm going to put that for LED, and the max 1000, so 1 second, more than that. So if I'm above, what the mapping function is doing is, if I get a 10, you get 150. If I get 100, you get a second. Anything in between, we'll do a linear translation. And now here, instead of 75, I do my alarm divided by 2, exactly what I did by hand on the previous video. Let's compile. Let me turn on, it's already on, this guy. Let's do a serial print confirm the distance here when I do this one. Let's print the distance. Alright, good shape. Let's see if it works. Compiling, and we will see the LED blinking if I'm closer or further away from the object. So far away. As I get closer, closer, you see the LED getting blinking faster and slower. Great, this is with the LED. And let's move on to incorporate the alarm system. Alright, let's incorporate the buzzer now in our code. There is a slight problem right now with the passive buzzer. We need to switch to an active buzzer. The main reason is because this function over here, the tone function, shares the same internal timer as your ping sensor. So the ping sensor needs to use a timer to generate those waves, and this tone here is also using that same timer. So we have different options of solving these issues. So if you port the tone to your Arduino, it will give you an error and will complain about the timer. So we either option number one, we don't use the new ping sensor and we use our own way of generating those waves, and then we can use the tone and the passive buzzer. Or option number two, which is probably slightly easier, is if we use the active buzzer on your kit. And for the active buzzer, I don't need to use any library, and that's the one that I'm going to use. I already put the active buzzer into my circuit. I'm going to define the pin for the buzzer, pin number 8. I'm going to define the pin 8, my buzzer, as an output. And now all I need to do is, instead of being LED, is my buzzer goes high and goes low. I compile to see if everything is fine. I will have my wave and my terminal. Alright, it goes there and there. I'm going to turn on the buzzer here. Here you go. Alright, let's see if it works. As I get closer, at last, the only thing that we need to do now is just to complete or fix our block diagram, so everything is good to go, and probably do the last flowchart for this one. I'll do everything on this video. So things that I'm going to fix here: I'm going to add the value of the resistor. I have a 330 ohm resistor over there. I no longer have a passive buzzer. I actually switched that, and that's important because they operate differently. I have an active buzzer, and that's pretty much it regarding the new system. And now let's do the block diagram. I'm going to turn off this one, and the block diagram for our code starts with start. So inside of our setup we have, let's set up LED as an output, buzzer as an output. If you don't want to give these names, let's just erase these really quick. Let's put the names of the pins. So pin 2 and pin 8 and begin serial. We're doing all these 3 functions on your start. This is your setup. Now I have send ping. I have convert to distance and also print distance. Great. Then I have map to, let's actually be a little bit more descriptive here. Let's say map distance to alarm. Remember, mapping, it was just the easiest and fastest way of doing this. Probably not the best, but it does the job. And then at last we are blinking the LED and sounding the buzzer, so we can say blink LED and trigger. Let's call trigger the buzzer. Alright, and this is done, and it goes back to my send ping. Oops, sorry. And this is what it's inside of my loop, and this can be a possible flowchart for your system in conjunction with this block diagram. And here you go. We just did a project from the beginning to the end by incorporating concepts that we just learned, and we did this parking backup sensor system. Hopefully you guys like it. Again, you don't need to build any of these, just learn the process, learn about the block diagram, schematics, like the process of tackling an engineering problem. That's what you guys should take out of this lab. The complexity of the labs are going to vary. You don't need to do any you are not going to handle any resistors or transistors because you guys don't have prototype boards, some of you, and neither oscilloscopes, but schematics, block diagrams, whenever needed, are going to be required.